I pointed out that we have been looking at the rotation of a body in one plane, that is about one axis. So उसी की हमने expressions derive की थी for the velocity of different points on the body and the acceleration of various different points on the body. And we saw how this time around what's happening is कि हम लोग वो अगर polar components use करके इनको describe करें, फिर वो जो angular equivalents of rotation, of velocity, of displacement होते हैं, हम उनको एक नया नाम दे देते हैं because they are the same for the whole body. So what we call them this time around is the angular velocity is known as omega. That is, theta dot is omega, theta double dot is alpha, or to add on top of it is कि जो हमारा displacement होता था, that is now become कहाँ गया? Displacement has now become d theta because theta is the position and hence the displacement is d theta. और ये सारी की सारी d theta, alpha and omega, they are the same for the entire body as it undergoes rotation. ठीक? So using these sort of angular equivalents, then we can derive what the expressions would be for the absolute velocity and acceleration of any particle on the body. और हम देखते हैं कि उसके अंदर actually the radial position of that particle comes along. और उसी की वजह से because ये radius का function है सारी चीजें, velocity and acceleration, that's why each of the particle has its own motion. They all have their own motion and और इसीलिए हम इस पूरी rigid body के motion को पूरी तरह analyze कर रहे हैं. Right, so this is all that we've been doing. Or further to this, we'd seen that this analysis can be done either in a scalar form, just noting that these are these expressions and using the right hand grip rule to figure out the orientations or the directions of the rotatory vectors. But they can also be done using vector analysis in which there are cross products lying in there. So we just have to be careful about manipulating those cross products properly. Right. So with that, we've done one example of a motor causing a fan to rotate. So today I want to jump into the other example. So that's where we'll start today. So today we're jumping into solving another problem, but this time around the motor is being used to lift up a load. So in this case, what's happening is that starting from rest, when S is equals to 0, that is this load is lying on the ground, pulley A, the one that's attached to the motor, is given a constant angular acceleration of this, and then pulley C has an inner hub. So मोटर जो है वो कनेक्ट हुई हुई एक लार्जर व्हील के साथ और उसी व्हील का एक छोटा हब भी है, मतलब ये कि उसी के साथ एक और छोटा व्हील भी अटैच्ड है, उसके on top of which the cable is winding, जो केबल इस लोड B के साथ अटैच्ड है. तो जैसे A घूमेगा उस तरह C घूमेगा और C से D भी रोटेट करेगा because they're part of the same rigid body. And then as D rotates, this cable ends up being wound, so B lifts up. Perfect. So what do you want to do? You want to find the speed of block when it has risen by 6 meters. Okay, so again, I think you all can identify that we need to make certain assumptions about the behavior of the cable in order to be able to analyze this motion. There is, मतलब हमें assume करना ज़रूरी है, वरना हमारे पास इतनी information नहीं है कि हम इसको solve कर सकें. So one assumption we're going to be making is that the cable is inextensible, मतलब ये कि it doesn't stretch. And secondly, we're going to assume that it doesn't slip over pulley A or pulley C. Only then, if we assume that it's not slipping, then we know कि जो भी cable का यहाँ पे tangential behavior है ना, tangential, वही उसका behavior है यहाँ पे, ये वही उसका behavior है यहाँ पे, वही उसका behavior है यहाँ पे. That is, throughout फिर cable का वही tangential behavior रहता है. और tangential behavior से क्या मतलब है? It's the velocity and it's the tangential acceleration. Why? Because these two are dealing with velocity का अगर हम सिर्फ magnitude ले लें, the speed, then these two are dealing with sort of rates of changes in magnitude, right? So that will stay the same whether we're looking at the cable here or here or here in चीजों के magnitudes. Sure, their directions will be changing, but at least their magnitudes are going to be the same. Okay, so once we know that, तो फिर once knowing this about the cable, फिर we can figure out कि given a particular motion of the motor A, what is the motion of C being caused by it. और in turn अगर C का motion पता है तो फिर हमें D का पता है और D के motion से फिर हमें cable का पता है, right? So let's I hope you all have your pens and papers out, so let's start with this. So next thing to notice that we are only talking about acceleration here, so that's why I am just, and then look, I have to find the speed when it has risen by 6 meters, right? So this is going to be something, हम कौन सी वाली kinematic equation की तरफ जा रहे हैं, हमें speed find करनी है, that is velocity का magnitude given the distance, or something talking about constant accelerations. So that is इसके अंदर मुझे, और ये final velocity है, that is मुझे इसके अंदर velocityों की consideration करने की ज़रूरत नहीं है. If I find the constant acceleration that B rises by, I already know the distance that it has moved. I know that it starts from rest. So I think it's that expression that we're familiar with, that is V squared is equals to V naught squared plus 2AC S minus S naught. इसके अंदर just noting कि it starts from rest and it starts when S is equals to 0, so that all of those go to 0. So हमें सिर्फ और सिर्फ ये constant acceleration figure out करनी है. That's why I'm just not gonna consider the velocities of the cable. I'm just gonna try to find its accelerations. So now let's start. So we know that the tangential component of the cable will remain unchanged. So that is whether I find AT using the motor or using the wheel C, that would be the same. So motor say it would be, if you guys don't remember yet, let's write those down. V is equals to omega R. Alpha, oh, sorry. A tangential, the acceleration which is in the velocity's direction, right? दोनों tangential होते हैं, ये velocity और AT. So इसका भी expression ना, it's very similar to V. So V के अंदर omega R था, तो यही acceleration जो velocity की direction में है, वो alpha R है. And then the normal component is the other one, which is the omega squared R. That's how I've memorized these. Of course, you don't need to memorize them, but it's useful to have them at the top of your head. So the tangential acceleration, which is in the direction of velocity, of course, has a similar expression to velocity. So here we'll have alpha motor, जो A का नाम है, alpha A, R A is going to be equal to alpha C R C. Note here कि वो radius है because the cable is touching or is in contact with the outer ends of the motor pulley and the wheel C. Okay, so substituting stuff in here, 6 times 50 is equals to 150. So this gives us alpha C is equals to 2 radian per second square. Sensible, because we've gone for a smaller wheel to a larger one, so the angular acceleration has decreased. Now we know okay, C and D are part of the same rigid body, so that means that the angular acceleration of D is going to be the same as the angular acceleration of C. Next, as we had considered that rotating pulley, the same thing is going to be happening for rotating cable. The same thing is going to be happening for this cable. That is कि whatever its tangential components are here, they are going to be the same throughout, और वही इस लोड बी की वेलोसिटी और एक्सेलरेशन होगी. जो भी इस केबल की tangential acceleration or velocity होंगे at this point. So whatever its velocity and tangential acceleration are here, वही will be the velocity and tangential acceleration of B. Okay. So I just want to point out also कि इनकी directions of rotation क्या है. Alpha A was like this, so alpha C is like so, and alpha D is also hence in the anti-clockwise direction, and hence it makes sense that the cable has a upwards acceleration. So let's find that. So the acceleration of, I'll write that down here. The acceleration of B is actually equal to the AT, the tangential acceleration of the cable over the wheel D. Does that make sense? Acceleration of B is the tangential acceleration at D of the cable. So that is going to be, of course, alpha D RD. So then that comes up as 2 times 75 millimeters. So that's 0.075, which is of course 0.15 meter per second square. Now that I know what the constant acceleration is of B, here I can substitute it into my velocity expression for constant acceleration and figure it out. So V squared is, as I've seen in my case, 2AC. So 0.15 times 6, which implies that the velocity is equals to, क्या आ रही है जी please? Is that correct?
Yes, ma'am.
ठीक है जी. So pretty straightforward question. Again, the most important thing out of this one is to note कि वो tangential components जो है ना पुली के या केबल के, वो सेम रहते हैं थ्रू आउट इट्स मोशन. उनका मैग्नीट्यूड सेम रहता है एटलीस्ट. So the velocity and the tangential acceleration are pretty important to note for cable driven systems like so, where we have pulleys and cables working together. Okay, right. So any questions for this? No? Right, then let's jump into our next topic. We will get much more practice of rotatory motion. So don't think कि बस दो examples हो गए, because what we're about to start off next also involves rotation. As you guys know, we discussed that there are 3 types of motion of a rigid body within one plane. One was translation, the second was rotation about a fixed axis, and the third one was when you have both rotation and translation. Okay, that was general planar motion of a rigid body. Now of course अगर general planar motion के अंदर translation भी है, rotation भी है, तो अभी हम देखेंगे कि हमें वो भी दोनों चीज़ें दोबारा डिटेल में practice करने को मिलेंगी. But except के for general planar motion, the analysis is a little bit more complicated, and we'll just see how to analyze those. So first of all, I want to point out that we're going to break down the general planar motion analysis into 2 lectures. One, we're just going to be considering the velocity today, and then later on we'll move to the acceleration. Okay, so for today, let's just jump into how do we figure out what the velocity of a point on a rigid body will be if it's undergoing both translation and rotation at the same time. Now, for that, I want to notice I want you guys to notice exactly this कि अभी हम यही कह रहे हैं कि जनरल प्लेन मोशन के अंदर ये दोनों चीजें हैं, ट्रांसलेशन भी है, रोटेशन भी है. So why not we actually consider it to be a sum of these? Why don't we consider the general plane motion to be translation plus a rotation? That is, हम ये करना है, it's both of them occurring. So why don't we separate those two effects out and then consider each of them, and when we add those two effects together, we'll get the total general motion of a rigid body. ठीक है? So this technique or this sort of way of thinking about it, thinking about the problem being composed of two separate things which are then added up, helps uh, helps us simplify the analysis significantly, as you'll see shortly. So that's one thing that I want you guys to notice, कि हम general plane motion को translation और rotation के sum के तौर पे consider करेंगे. Secondly, I also want to go back to noting that when we're looking at a rigid body, then we can always consider the motion of one point on the body relative to motion of another point on the body. हमने पहले भी translation के लिए भी यही consider किया था, to show that all points have the same velocity and acceleration. But this time around, we'll see how this will come to be useful to us. So that is what we're saying, is that we are going to be considering a relative motion analysis of different points on the body relative to one chosen point on the body. Okay, so now so those are the two basic, that's going to be our scheme of analysis. The scheme being that we're breaking down the motion into two separate components, translation and rotation. And secondly, we're going to be using relative motion analysis to figure out if we already know, let's say, the motion of one point, then what is the motion of other points on the body relative to that one. Okay, so with that, let's start to set up the problem. First of all, of course, abhi I haven't drawn the motion of the rigid body. I've just drawn it as it is, just to introduce the coordinate systems. So first of all, let's have our fixed coordinate system right here. Or of course, this fixed coordinate system is, let's say, it's our inertial frame of reference where we are standing perhaps and measuring the total the absolute velocity or position of particle A and B. So from this fixed coordinate system, of course, as I just said, ये जो position vectors हैं RB and RA, they represent our absolute positions of these two points on the rigid body. Now, let me also introduce a moving frame of reference, a frame of reference that moves with the rigid body. And that for that one, I'm actually going to choose the origin to be lying on this point A. Or why I've done that is perhaps I actually already know the motion of A. That's why I'm going to consider A to be my base point on this rigid body. So on this A, I place a translating coordinate system. That is a coordinate system that moves with the rigid body. But one extremely important thing to note is कि ये जो moving frame of reference है ना, it is only translating. It is not going to rotate. So इसीलिए if you notice कि ये x और y directions के parallel हैं x prime और y prime directions. So no matter कि rigid body किस तरह rotate कर जाए, maybe वो इस तरह है, अभी बाद में वो उसका कुछ direction यूं rotate हो जाती है या कुछ हो जाता है. लेकिन what I'm gonna do is कि I'm always gonna place my translating coordinate system in the same orientation as it was before. That is, I'm only going to translate this frame of reference, nothing else. Okay. Now, yes. So those just these things to point out. that I have my fixed coordinate system relative, the fixed coordinate system from which I'm measuring my absolute positions. But then I also have a translating coordinate system which is placed on one of my one point on the body, or I've chosen that point because I already know the motion of that point, and that's why I'm going to be calling it my base point. And relative to this point, I'm going to then be defining the positions of all other points. इसीलिए B की position relative to A is going to be this RB given A position vector. Okay, so now that we've popped these two things, okay, there's a fixed coordinate system, and there's a translating coordinate system. Now let's look at the general planar motion of that rigid body. So consider कि वो rigid body initially इस time पे it was like this, and then it moves because of both translation and rotation to a new position right here. Now clearly जो point A था, which is my base point, ठीक है, ये A मैं अभी A को ही अपना base point लेती रहूंगी, ठीक है जी. So A जो है that has moved to its new position right here, and B has moved to its new position right here. So of course जो change in position होती है that is the displacement. So clearly A की displacement is this dRA और B की displacement is this dRB. ठीक है, so we are going to try to figure out what these are. First of all, note कि A was my base point. So I'm going to assume कि जो dRA है ना, ये मुझे पता, इसका मोशन मुझे पता है. और अब उससे मेरे पास एक हिंट आने लगी है, which is कि as I said to you guys that I'm going to break down the general plane motion into two problems. One is going to be translation, and then add on top of that a rotation. So now let's see how that works. I'm going to try to attempt to draw it out, and of course my drawing, as you've seen, is a little rusty, but let's try our best. So what I'm going to do is let me place मेरा वही fixed coordinate system ये रहा, और मेरा जो translating frame of reference था वो इसके ऊपर place था, right, on my base point x prime y prime. So अभी आप देखें मैं उसको translation और rotation में किस तरह build down करती हूँ. What I'm going to do is I'm going to assume कि जो ये A का motion था ना, जो मुझे पता है मेरे base point का, उस पूरे के पूरे को ही ना ट्रांसलेशन के तौर पे ले लेते हैं. मतलब ये कि उस पूरे के पूरे को ही मैं उधर से इधर ले आती हूँ, x प्राइम y प्राइम यहाँ आ जाता है फ्रॉम इट्स इनिशियल वन जो कि वो इधर कहीं था, सच दैट नाउ ट्रांसलेशन से सिर्फ बॉडी जो है वो वैसी की वैसी ही ओरिएंटेशन में रही, ये मैं वही बना रही हूँ, और A यहाँ आ गया और B यहाँ आ गया, गिवन के ओरिजिनली वो उसी ओरिएंटेशन में यहाँ थे. दैट इज मैंने पूरी बॉडी को ना DRA से ट्रांसलेट कर दिया है, A को भी और इवन B को भी. नाउ क्लियरली ये B तो DRB से एक्चुअली मूव हुआ है. It's not been translated just, right? So that's why this is not its final position. This is going to be some sort of just a position because of translation. और अभी सिर्फ हम फाइनल पोजीशन पे नहीं पहुंचे, सिर्फ किस चीज की फाइनल पोजीशन पे पहुंचे हैं, ए की. तो अब I want to get the rest of the points on the body to their final position. So then I'm just going to have a rotation about my point, the new position of A, that is about my यही वो translating frame of reference के origin के तौर पे. तो इसको that is I'm going to be considering it to be fixed, and about it I'm going to make this entire rigid body rotate. और अब मैं ये करूँ उसकी रोटेशन थोड़ी सी, ओके. सो देन बी इधर से रोटेट होके कहीं अपनी ओरिजिन ट्रू रियल पोजीशन बी फाइनल पोजीशन पे पहुंच गया है। तो दैट इज वो इधर जहां पे भी मैंने अभी ट्रांसलेशन के बाद उसे रखा था बी प्राइम पे, उससे वो रोटेट करके इधर आ गया है। So that is, I first just assume कि the base point is the one जो उसकी ट्रांसलेशन हो रही है, पूरी रिजिड बॉडी जो है वो उसी के साथ उसी तरह ट्रांसलेट कर गई है। और फिर then to actually get to the real general plane motion position, I'm then going to rotate about that base point. Does that makes sense a little bit, I hope? So does any अभी ये clear है या unclear? Because I'm about to remove the drawing that I've made to bring up the proper one. But I think it makes more sense if we do it one at a time like this.
मैम ए पॉइंट नहीं रोटेट होएगा।
A point क्योंकि look हमने इन दोनों को sum करना है to get to our फाइनल पोजीशन, राइट? सो ए को तो हमने पहले ही अपनी ट्रू पोजीशन पे पहुंचा दिया, उसकी पहले ही डिस्प्लेसमेंट डीआरए हो गई है और उसकी असल में भी डीआरए है, तो अब ए को तो मूव करवाने की जरूरत नहीं है रोटेशन से। यू गेट राइट? द ए ए की ट्रांसलेशन से ही उसका काम तमाम हो गया था।
ओके मैम।
Okay, so let's see this drawn out a little bit better. और इस पे वही चीजें बट दोनों साथ drawn in है। Now let's see, oh, as I'd been saying, कि let's just first translate everything by the same amount as the base point. So जब हमने खाली ट्रांसलेशन कर दी तो A got to its final position, लेकिन B के साथ क्या हुआ? B को अगर हम DRA से ही ट्रांसलेट करेंगे, ये रहा DRA, तो वो तो सिर्फ B प्राइम तक पहुंच गया। फिर हमें क्या करना है? हमें ऑन टॉप ऑफ दैट वी हैव टू ऐड ए रोटेशन अबाउट ए, ताकि बी अपनी ट्रू फाइनल पोजीशन तक पहुंचे। सो दिस वन इज ड्यू टू ट्रांसलेशन and then this one is due to rotation, and then when we add these two up, then we get our final total displacement of the point B. I hope that makes sense. Now there are a few further things to point out, which is के मैंने translation और rotation का तो clear कर दिया, but also what are these vectors in terms of sort of vector analysis या फिर in terms of relative motion. So the first one is just DRA, because everything is being translated by the amount that A translated by, so DRA हो गया। लेकिन जो ये rotation वाला है ना, and I want you to focus on this now, this rotation one. This is now the relative displacement of B with respect to A. Why? Because मतलब ये अब इसको देखें क्या है? It is D displacement of B with respect to A. Because यही तो था कि वो A को फिक्स रख के जो रोटेशन हो रही थी B की relative to A, तो उसका जो डिस्प्लेसमेंट होगी वो तो यही होगा ना, इट वुड बी द relative displacement of B with respect to A. Think about this one for a little while. When we had just initially translated everything, मतलब ये कि जब हम इस डार्क ब्लू वाले पे थे पहुंचे सिर्फ ट्रांसलेशन के बाद, तो तब तो ए और बी प्राइम, ये जो बी प्राइम है, तब तो ए और बी प्राइम वैसे के वैसे ही उनका relative position vector वैसा का वैसा ही रहा। That is कि at that time there was no relative displacement, relative change in position of A and B. It's only that this rotation वाला जो element आता है फिर जो हम add कर रहे हैं, that is the relative displacement of B with respect to A. Now, we can find this relative displacement by just, as always, using if we have small angles of rotation, then we know that ये जो line है, that is also going to be equal to the arc length. So clearly this dRBA is actually equal to the radius RBA multiplied by the angle of rotation d theta. That is displacement of B with respect to A, वो जो rotation की वजह से हो रही है, that is actually equal to the relative position of B with respect to A. इन दोनों का आपस में क्या distance है, multiplied by d theta. Perfect. So now that we've got all of these lined up, let's just write this down as a vector form and note that the total displacement drB of the point B is going to just be the sum of the displacement due to translation, or that is dRA, because everything we will first just translate by the amount of the base point. So सब कुछ DRA से मूव हुआ, उसके बाद जो उसकी हमें और डिस्प्लेसमेंट चाहिए वो आएगी because of the displacement of B with respect to A. So that's then the displacement due to rotation. Perfect, perfect. So I hope Abhi, any questions for this breakdown into translation and rotation? So अगर आते जाएंगे तो we will keep clarifying, don't worry. So उसी चीज की एक और example. Now consider when we have a wheel which is going forwards. So notice कि इसमें क्या हो रहा है, अगर if I have the center of the wheel like so, उसकी तो यही final position भी रहती है. But a point on the circumference that rotates downwards, right? It moves downwards. So overall, there's been translation and rotation of the entire rigid body. तो इसको भी हम break down कर सकते हैं as we've just done to make sense of it. That we choose our point, base point, जिसका motion हमें known है, right? Of course हमें center का motion इसका known है. और हम सब कुछ को उतना ही ट्रांसलेट कर देते हैं जितना वो बेस पॉइंट ट्रांसलेट हुआ होता है. So that's why A की amount से everything gets translated first, and then we add on top of it the rotation about that point A. That is, we are treating our general planar motion as the sum of translation and rotation. ठीक है? Similarly, for a sort of an arbitrarily shaped rigid body, the same thing. First, we translate everything by the same amount as the base point, ये base point है, and then we rotate about the base point, as we've done like so, to get the rest of the rigid body to its final position.
मैम
Okay.
जो ट्रांसलेशन है वो रेक्टिलिनियर होना लाजमी है?
Great question. नहीं. No, it does not. Let me show you. If I go back here, if you're just looking at it in the Cartesian coordinate system, जो हमने x और y बनाए हुए थे, तो फिर even though let me just describe this, even though this, ये आप देखें ये DRA भी ऊपर की तरफ जा रहा है ना, मतलब ये कि even though this might have moved about a curved path, something like this, then the displacement is still, it's going from the initial to the final position. So we have actually lost the information that it went in the curved path. All that we've just, for now at least, have considered is कि उसकी initial position क्या है और उसकी final position क्या है. That is, we've just looked at it as a vector. ठीक? So in the Cartesian coordinates, वो vector will always be just, it won't be able to have that information of the curved path or not. For now. Okay. Right. The second thing just to note is कि अभी ना we haven't managed, and you'll see that this is a little bit of a problem, but what we're doing right now is that we're just looking at an infinitesimal change in time. मतलब ये कि अभी हमने बिल्कुल ही we haven't managed to consider कि उसका पूरी duration में time के क्या motion है उसका. We've just started to consider कि at this instant अभी just right now वो कैसे move कर रहा है, वो infinitesimal displacement क्या है. So infinitesimal displacement के लिए वो curved हो या ना हो, that will still it doesn't matter to us, right? Whereas for large duration, that is हम instantaneous को जब खत्म करना शुरू करेंगे, फिर these things will start to concern us. But for now, we can only look at an instant. अभी तक जो हमने describe किया है. Okay. Yes. So now we've got our displacement in place. So I want to try to get our velocities working. So we just noted if I'm looking at a rigid body or mera A is my base point, then any other point on the body, uski displacement will be drb is going to be dra plus the relative displacement of b with respect to a, right? And further I have noted कि drba है क्या. I noted कि that is just the मतलब जो radial या फिर जो distance है between b and a multiplied by the angle of rotation, the small angle. Instantaneously हम देख रहे थे d theta. So now if I want to get to the velocities, I just need to divide all of this through by dt, or इससे I can see that this drb by dt of course is the absolute velocity of b, dra by dt is the absolute velocity of a, और इधर क्या चीज आ गई है, इधर I seem to have rb by a multiplied by what, d theta by dt, which is what, do you remember?
Omega.
Omega, exactly right. So this is the angular velocity of the rigid body, वो जो उसका rotation वाला part था उसके अंदर. And that makes sense. Isn't this familiar? Isn't this omega r the one that we are used to seeing? One more thing that I'm going to do is because we have the velocity of b with respect to a, मतलब ये कि b is rotating with respect to a, that's why for now I'm just going to pop in that is the angular velocity of b with respect to a. But we'll see shortly this is just it is the same for the entire can you guys hear me?
Yes, ma'am.
Yes, ma'am.
Okay. ठीक है जी, sorry I light चली गई थी. Okay, so coming back here, I was just pointing out, isn't this familiar? This is the velocity of a body because of rotation. याद है v is equals to omega r. So जाहिर है वही होएगा जब वो rigid body हम कह रहे हैं कि a के about rotate कर रही है, तो वो जो velocity आएगी वो वही होनी है ना, फिर rotation की वजह से थी वो relative velocity. So that's extremely useful to us because further just इसको थोड़ा सा और manipulate करना शुरू करते हैं कि I know कि I can write this down in various different ways. Not various actually, sorry, just अभी तक मैं scalar version लिख रही थी ना. Let me just convert this into the vector version. And we know कि इसका क्या order होता है, that is omega BA vector crossed with RBA. Because the velocity we know in the vector form for rotation is omega crossed with r. So neat. This is basically हमारे पास we've gotten our velocity of any other point using the velocity of the base point, and then noting that the rest of it is rotating about our base point to get our general planar motion. ठीक? Now this is pretty important, and it's worth that I just write it down right here, because the rest I'll have to remove to bring up a graphical picture of that. So VB is equals to VA plus omega BA crossed with RB with respect to A. This is right here, by the way. Also note, if I did not point that out before, actually I did not, okay, this one right here, it can also be referred to as the relative velocity of B with respect to A, right? Relative velocity है ना, क्योंकि वो B A के relative rotate कर रहा है, so it's the relative velocity of B with respect to A. Now let's see graphically what they would look like. Let me consider I have again this rigid body, and it is undergoing both general plane, both rotation, translation, and rotation. So when that happens, as we've discussed, we're going to break it down into first just translating with A, and then a rotation about A. So अगर translation with A करना है तो फिर तो हर चीज, all of the body would get translated by VA, और फिर हम rotation करेंगे about our base point. So इसीलिए now you notice, now if you notice कि अगर if I've drawn it correctly graphically, so what I can do is I can pop these things here VB के ऊपर to just check कि ये they should be following our our head to tail rule. So ये VA आ गया, और इसके अंदर add करें VB by A to get my resultant VB, और यही हो रहा है, बिल्कुल ठीक है. So so even graphically we can perform this vector addition, the separating out the translation and rotation. अच्छा, इसके अंदर ना there are a few extra things that we should note and point out which are extremely important about the relative velocity. इस पे ज़रा focus कीजिएगा for just a few minutes, right? First of all, notice कि this VB by A, this is rotation about A. तो जब कोई रोटेशन हो रही होती है तो कोई भी पॉइंट किस किस्म की पाथ फॉलो करता है, तो बी का पाथ विद रिस्पेक्ट टू ए क्या होगा? Circular path, exactly right. So B is going to be ये मेरा attempt at a circle था. B is going to be moving about A in a circular path. मतलब ये कि उसकी velocity की जो direction है, that is of course going to be tangential to that circular path, right? तो velocity tangential, और ये क्या है, ये VB with respect to A है, the relative velocity. उसका tangential to the circular path होने का एक और तरीका है कहने का, that is that it is going to be perpendicular to this line joining B and A together. and इतनी ज़्यादा चीज़ें ड्रॉ करके घिच-पिच कर दिया है. I'm just trying to point out that this relative velocity is always going to be perpendicular to RBA. That is, we already know something about this velocity. हमें इसके बारे, इसकी direction की information ना already known है. That helps us to evaluate things. Of course, जब हमारे पास ये piece of information हो. Let's say अभी मुझे graphically इधर बनाना होता, so what I can do is I can already draw a line perpendicular to this one, क्योंकि मुझे उससे पहले ही पता चल जाता है कि वो रोटेशन तो इसके परपेंडिकुलर ही होनी जरूरी है। और फिर वी ए की लाइन अगर मैं इसके पैरेलल वी ए के पैरेलल बनाती फिर अगली, सो इन दोनों की जस्ट इंटरसेक्शन से ही है, इस किस्म के ग्राफिकल मेथड्स ही यूज करके आई वुड हैव फिगर्ड आउट माय टू वी एज एंड वी बी बाय ए, right? So I'm just trying to point out that there are tiny bits and pieces of information that we already have available just by our given by our initial problem. One of these is this direction of the relative velocity Vb by A. Okay, it will always be perpendicular to the relative position of B with respect to A, या फिर the line joining B and A. If you don't like this way कि अच्छा हाँ उसने circular path पे move करना है, then there is another way to think about it which is also pretty straightforward, which is कि we know that this VBA, that's the one arising because of rotation omega crossed with RBA. तो ये तो हमें पता है कि क्रॉस प्रोडक्ट का जो एंड रिजल्ट होता है that is perpendicular to both the terms in the cross product. दैट इज VBA जो है वो इसके भी परपेंडिकुलर होगा और इसके भी परपेंडिकुलर होगा। तो यही तो मैं कह रही हूँ कि वो इसके RBA के परपेंडिकुलर है। That's exactly what we are seeing, right? So either way you guys like to think about it, either in the vector way या फिर just कि वो physically rotation का क्या मतलब है। We know that the relative velocity is going to be perpendicular to this RB by A. Great. Okay. So with that, let's jot all of this, reinforce this and write this down again. So as we've just discussed that VB is just the sum of the translation and the rotation. The translation by the amount of the base point and then rotation about that base point. Further, we also know that this relative velocity Vb by A is it's because it's arising out of the rotation, we can write it down as omega r or omega crossed with r, noting that then it will be perpendicular to RBA. Okay. So just with all of that, we have our velocity for a point B given a base point's velocity. Perfect. Acha ji, now the time is 9:51. We'll just carry on for a few more minutes before we stop and then take the quiz. Okay. So I just want to start with an introduction to a one problem. Acha, इधर मैंने ये I also want to point out that all of these things are bold-faced because these are vectors, right? So abhi to I know I was mildly talking about some graphical approach. वो भी vector analysis पे ही based है. But the another thing to note is कि अगर हम I J के components या फिर कोई भी vector components के तौर पे कर रहे हो तो फिर हम इस problem को, इस equation को straightforward vector analysis से भी solve कर सकते हैं। मतलब ये कि हमें कोई ये परपेंडिकुलर होना ना होना इसके बारे में सोचना नहीं पड़ता। हम बिल्कुल ही अंधाधुन आई जे के कंपोनेंट्स लिखें और क्रॉस मल्टीप्लाई करें एंड सो ऑन, और वो जो उसकी इंडिविजुअल आई जे और के की एक्सप्रेशंस निकलेंगी उनको सॉल्व करें, देन वी विल बी एबल टू फाइंड विच एवर वन ऑफ दीज इज आर अननोन, राइट? मतलब straightforward vector analysis does apply to this equation. But for just temporarily, let me allow me to focus on the graphical approach, which is basically a scalar approach, just because the scalar approach या फिर the graphical approach emphasizes the physics of the problem. मतलब आपको physically समझ आ रहा होता है कि क्या हो रहा है. So for example, let me consider this one link mechanism right here, where this link has its two ends being confined to one a horizontal channel and the other end being confined to a vertical channel. Now, because as it, let's say uske ye end B moves down, A will move to the right because it's confined. और इसकी वजह से अगर आप इसके अगले इंस्टेंस को ड्रॉ करें ना तो we know कि it would have undergone both translation and rotation. So that is, it undergoes general planar motion. लेकिन हमने अब देख लिया है कि हम जनरल प्लेन मोशन को किस तरह एनालाइज करते हैं. वी ब्रेक इट डाउन इनटू ट्रांसलेशन एंड रोटेशन. ठीक. सो लेट्स अज्यूम कि वी हैव आवर बेस पॉइंट एज ए. देन एज वी ऑलरेडी नोटेड कि हमने क्या करना है, हमने हर चीज को ए से ए की ही अमाउंट से ट्रांसलेट कर देना है. मतलब ये कि ए भी उतने से ट्रांसलेट हुआ, बी भी उतने से ही ट्रांसलेट हो गया. That's why B also has this VA. And then we are going to rotate about our base point to get our relative velocity, ताकि finally if I draw my if I draw my head to tail rule, I actually get back कि मेरा resultant VB is वही कि V पहले उसने translate किया और फिर उसने rotate किया. So I get back my resultant velocity. Now because I already knew कि VB जो है उसने vertical होना है, VA जो है उसने horizontal होना है, and then I also knew कि जी जो VB by A है, the relative velocity that's going to be perpendicular to this one. So because of all of those informations, they were enough for me to draw this out. Even if अगर मुझे इनकी magnitudes ना पता होते तो मैं फिर भी ये ट्रायंगल ड्रॉ कर सकती थी just by knowing this much. ठीक. और उसी से once I pop in this triangle, noting के at this instant जो भी इसकी geometry है ना, again I do want to emphasize that this is all instantaneous. हमें उसका कुछ नहीं पता आगे क्या होगा पीछे क्या होगा, क्योंकि वो सब चेंज हो जाएगा. बट एट दिस, अगर इस पिक्चर पे हम स्नैपशॉट ले लें तो इस मोमेंट पे हम उनकी वेलोसिटीज को फाइंड आउट कर सकते हैं. Okay, so consider that at this moment, this angle is theta. Now this is not our angular position or whatnot, it's just an angle theta. Theta की जगह मैं उसे phi कर देती हूँ ताकि that removes the confusion. So I want you to notice कि if this is phi, then I can figure out कि मेरी इस diagram के अंदर, this vector diagram के अंदर बाकी angles क्या हैं. For example, I know, as I said, I know कि VB is vertical. तो ये ड्रॉ कर ले. फिर उसी से हम एक लेट्स से VA का भी पता है हमें कि दैट इज हॉरिजॉन्टल. अब नाउ आई हैव टू गेट टू दिस रिजल्टेंट VB. VA ये है. नेक्स्ट लेट मी आल्सो, आई नो कि ये थीटा फाई एंगल पे था ये, तो मैं इधर एक फाई एंगल क्यों ना बना लूं. ये फाई पे था ना यूं. नाउ फर्दर आई आल्सो नो कि जो रिलेटिव वेलोसिटी आनी है दैट इज गोइंग टू बी परपेंडिकुलर टू दिस वन, है कि नहीं. It's going to be perpendicular. So then clearly I can see if this is angle phi, then this is 90 minus phi. और अब मैं इस पूरे को अगर देखूं, so then this angle is phi. And that's how I've gotten to this one, with the knowledge that this VB by A, ये वाली, is going to be perpendicular to my link AB. Okay, we will practice this more in a little bit, but I just wanted to point this thing out. So just let's pause here, noting that we can draw our vectors using sort of head to tail rule and just some information about their directions, and then use trigonometry to solve them. So we'll pause here and then we'll pick up solving this using trigonometry after the quiz. So let's jump back in. Right, so where were we? We were looking at this link और उसके motion को हम analyze कर रहे थे using a diagrammatic approach where we had this general planar motion, और हम इधर ये हमने draw कर लिया था. अब now the point was कि just using some information about their directions, and we had managed to draw in our diagram containing all the velocities, which is why क्योंकि इसके अंदर जो vectors हैं they are velocities, that's why this thing is known as a velocity diagram. So we managed to draw the velocity diagram, and now we can just use straightforward trigonometry to find any one of the unknowns. Let's say कि हमें ना ये velocity of A पता थी, हमें पता था कि A कितनी velocity से to the right move कर रहा है. So then अब trigonometry से we can directly find कि VB क्या है. I can see that VB is just VA tangent theta. एक तो बात. दूसरा ये मे बी I want to find the relative velocity. Maybe मैं rotation के बारे में कुछ find करना चाहती हूँ. So then let's see. For that as well we have our trigonometric identity for that one, which is VA divided by the base divided by the hypotenuse is going to be equal to cos theta. Now just note कि the relative velocity of B with respect to A जो है उसको हमें पता है कि that's going to be omega crossed with RBA. या फिर उसका magnitude is just going to be omega R, which in this case is what? R is L. So it's omega L. So वो भी we can pop that in to find what omega turns out to be. Ah yes, and finally forgot to say, because it's the relative velocity of B with respect to A, so this I'm going to call omega BA. मतलब ये कि हम ये omega BA भी find कर सकते हैं. So that is, we can find all the information that we may require or we may be interested in. Let me just consider what happens if instead of A, I use B as my base point. Let's say because मुझे B की velocity पता थी. अब उससे क्या होगा? Let's see. Again, we break it down into translation and rotation, but this time around, everything is going to get translated with the velocity of B. So इसलिए ये A के ऊपर भी VB लग गया. और फिर the rotation is going to be about B. So this time the relative velocity of course is going to be perpendicular again, but when I draw my head to tail rule I can see कि ये VB तो नीचे आ रहा है और मुझे VA तक पहुंचने के लिए to get to my resultant, then I have this VA by velocity of A with respect to B, which is going in this upwards direction. So if you notice, I'm getting the same triangle as before. The only difference is कि relative velocity की direction swap हो गई है, reverse हो गई है, sorry. और that's also not something very surprising, because हम लोगों को अपने वो relative motion analysis से पहले ही पता है कि अगर हम ये swap कर देते होते हैं, so VA by B is actually equals to minus VB by A. काम आसान हो गया. तो ये तो हमें पहले ही पता थी बात. So no, nothing fancy, nothing new, just the direction of the relative velocity gets reversed. The rest of the velocity diagram remains exactly as it is. What about the angular velocity? Now, I'm not gonna go into it, but you're more than welcome to try it out और वही trigonometric identity करके draw करने की कोशिश करें. You will see that in this case, it's velocity of A with respect to B. So this time around we have omega AB. We will see that omega AB just turns out to be directly equal to omega BA in everything, magnitude and direction. That is why पीछे और इधर उधर ना the angular velocity ko we have no concern if it's AB or omega BA, because they are unchanged. So the angular velocity remains, it's just the angular velocity for the body, no matter whether you take A to be your base point or whether you take B to be your base point or whether you take somewhere in the middle some random other point in the base point as the base point. Perfect. So just these comments right here, that the angular velocity, as I've just said, does not depend on our base point. Uska direction or magnitude will come out to be the same. It's only the direction of the relative velocity that reverses. Okay. Right. So I think we've understood now quite a bit about analyzing velocity for general planar motion. Now let me just set up some sort of steps. Okay, how do we go about drawing? अगर हम scalar draw करके try कर रहे हैं, तो how do we go about drawing it? Vector analysis के लिए तो it's just as I said, ij के कंपोनेंट्स हैं, अंधाधुन सिर्फ अरिथमेटिक सॉल्व करना है। लेकिन ग्राफिकल अप्रोच के अंदर थोड़ी फिजिकली प्रॉब्लम के बारे में सोचना पड़ता है। सो नाउ लेट्स जस्ट डिस्कस द ग्राफिकल अप्रोच फर्दर फॉर अ लिटिल बिट, द स्केलर अप्रोच फॉर अ बिट लॉन्गर। सो फर्स्ट ऑफ ऑल व्हाट आई वांट टू पॉइंट आउट इज whenever we're choosing our reference points or base points or even our points of interest, so most of the time we are interested in points जहाँ पे कोई कनेक्शन हो, जहाँ पे कोई पिन लगा हुआ हो और दो चीजें आपस में कनेक्ट हो रही हो। So for example, whenever we have this, एक mechanism की example ले लें, like the one shown here, again जिसमें एक rotatory motion is being converted into translation. For this, if I notice ये जो मेरा link AB है, this is the one which is a little important to me because B का motion I can find out using the motion of just BC, और A का motion फिर मैं AB के analysis से let's say determine कर सकती हूँ, ठीक। और if you notice इसमें भी I'll just point it out to you कि the AB link is going to undergo general planar motion. Okay, so हमें ये अपने relative motion analysis apply करना पड़ेगा। अब now let's say कि I already know the, क्योंकि मुझे पता है ये ओमेगा BC क्या है, ये किससे रोटेट कर रहा है, इसलिए मुझे इसकी वेलोसिटी का पता है, B की वेलोसिटी का, राइट। B is also part of BC as it is a part of BA. So I know कि B relative to C will be going around some circular path that is, that is B की velocity will be tangential to this BC rod, right? So it will be perpendicular to this. Next, I think you guys can all spot also कि अब let's say कि मुझे VB से जाना है to find कि इस piston की क्या velocity होगी. So I think you all can spot कि A I can see is going to be horizontal क्योंकि it's confined to that. So that is, I can actually already draw in कि what will be the directions of these two points of interest to us. Sorry. So now knowing the directions of these two velocities, then let's come up with some systematic way to figure out कि मुझे अगर VB पता हो तो मैं VA किस तरह find करूँ. That is, I want to draw that velocity diagram. Let's try it out. So I'm gonna break it down into basically 4 or 5 steps. और एक एक के साथ ना मैं 1 2 3 4 लिखने लगी हूँ. So the first step that I'm gonna have is I'm gonna draw in ये जो रिजल्टेंट मुझे पता है ना कि उनकी फाइनल वेलोसिटीज क्या होनी चाहिए after general planar motion. I'm just going to pop that in. So I know कि VA has to be something like this. And then I also have some information about VB. I think I know okay, it is going to be at 45 degrees from the horizontal. So this is going to be my VB. I'm trying to draw it as much as possible to scale as I can. I think you all know कि graphical approaches में we have to, ये randomly नहीं, अभी even though मैं ये कर रही हूँ, मैं by hand draw कर रही हूँ, but we do need some scale and some a protractor to figure out the angles and so on. So this is my 45 degrees, roughly. Now, you remember that we're going to break this down into translation and rotation. Now, my B point is going to be my base point, my reference point, my base point, right? So what I'm going to do is I'm going to make everything translate by the same amount. That is, ये भी यूं चला गया. Or who else? A is also going to go like so. फिर क्या होगा? So this is my point, step 2. I have drawn in the translation. फिर I'm just going to pop in कि अब rotation होने लगी है about B. So I'm going to keep this fixed. So I have my translation. And now I'm going to get my relative velocity of A with respect to B because of rotation. B is fixed. सबसे पहले ना रोटेशन की वेलोसिटी ड्रॉ करने से पहले व्हाट आई एम गोइंग टू डू इज आई एम गोइंग टू ड्रॉ आउट कि उस रोटेशन की किस डायरेक्शन में वेलोसिटी हो सकती है। नाउ आई नो कि अगर वो रोटेशन हो रही है अबाउट, मुझे नहीं पता डायरेक्शन क्या है, मैंने अभी नहीं ड्रॉ किया कि ऊपर की क्लॉकवाइज है या एंटी क्लॉकवाइज है। What I do know is कि वो वी बी बाई ए जो है हैज टू बी परपेंडिकुलर टू दिस आर ए बी. So I'm just going to draw in the sense of the direction like so. The reason that I've done that is, now let's come to my, अब ये मेरा था third step to just draw the direction. Now comes my fourth step, which is I'm actually going to go back to my final, जो मेरी ओरिजिनल मैं शुरू किया था with my resultant velocities, और उसके ऊपर I'm going to start to draw in कि VA तक पहुंचने के लिए this is my resultant, how do I get there? So I have noted some things down. First of all, I can see कि मेरा VB has to be this one. So then I can draw in my VB. ये मेरा VA था. And next I have also noted down that this has to be perpendicular. इसकी direction क्या है? So I already know it has to be like this. So that's why I then know that this is going to be my VA with respect to B. So I have completed my velocity diagram, and here now I can see that this is VA with respect to B. I can copy it from here and pop it right here. और इससे मुझे पता चल गया कि इसकी direction क्या होगी. It will be turning in this direction. Now that I've got everything, I have my full complete velocity diagram. उसको मैं थोड़ा बड़ा करके इधर draw कर देती हूँ just for my own ease. I knew this was, sorry, 45 degrees. This is VB. This is now VB by A. और ये रहा VA. Now using this just trigonometry I can find के अगर मुझे VB पता है तो VA क्या है, और also maybe if I'm interested in के इसकी angular velocity क्या है AB की, वो भी I can find from this. So that's my final fifth step. Now all of this may seem like a lot and long to you, लेकिन sorry, once you get pretty quick at it, फिर what people are able to do is कि वो directly velocity diagram के ऊपर ही ना वो सारी information करना शुरू कर देते हैं. Let me show you. So I hope you guys have noted down 1, 2. So first, सब resultant बना लें पहले ही कि क्या है. 2 is just the translation. 3 is के relative velocity की direction क्या होगी. 4 is to go back and pop in the, fill out those information in the velocity diagram to complete it, and then 5 is then to solve it in detail. ठीक. I'm gonna erase this. So screenshot ले लें या whatever you want to do, but I have to show you कि directly कैसे how people are able to do. So as I said, let me just first draw some information here. So I know this is going to be VB, I know this is going to be VA. अब आ जाते हैं हम directly velocity diagram पे. So I know VB क्या है, और इसकी मुझे length भी पता है और magnitude भी पता है, direction भी पता है, और I know it is at 45 degrees from the horizontal. Then what do I know? I know कि VA ने इस direction में होना है. And second, I know कि B by A has to be perpendicular to AB. Right? वो उसने इस direction में होना ज़रूरी है उसे. So that's it. और इससे मुझे सब पता चल गया फिर कि this must be the resultant VA and this must be my VA by B. That is, इसी के ऊपर directly people start to be able to manipulate it. Sorry. So I hope that makes sense to you guys. Yep, right. So just let's keep chugging along and take a look at perhaps another example of just this. Where else could we be using a base point and so on. So even एक wheel जो है ना, that's also an example जो मैंने पहले ही discuss किया of something undergoing general planar motion. What happens whenever you have a tire or a wheel rotating actually, और your गाड़ी आगे की तरफ जा रही होती है, is कि वो टायर का जो पॉइंट इज इन कांटेक्ट विद द ग्राउंड जो है ना, that's actually sticking to the ground and it does not slip. That is that base point. This acts as our base point because we then know that it is not moving. It has a velocity of 0 because it's stuck to the ground. और फिर क्या होता है ऊपर से the rest of it rotates about this point such that then it moves forward. और इसीलिए फिर अगले ये एक इंस्टेंट है बाय द वे मैंने आपको ये बात अभी 2-3 दफ़ा बोली है लेकिन मैं फिर से रिपीट कर दूं कि ये सब कुछ जो हम वेलोसिटी का एनालिसिस कर रहे हैं ना ये इट इज़ ओनली फॉर वन मोमेंट. अगले मोमेंट पे ऑफ कोर्स ए जो है इधर चला जाएगा तो ए की तो कोई वेलोसिटी आ जानी है ना, राइट? सो जस्ट बी वेरी केयरफुल अबाउट दिस कि it's only for one instant. So similarly here, I just trying to point out that even for wheels, we know some things about 2 points there. Well, we know that the center just will move horizontally with the horizontal velocity, and this point A remains at 0. So if using this information, we can then find out the case की let's say angular velocity क्या होगी. Of course वही बात है ना, VB is going to be equal to what? VA plus omega BA crossed with RBA. So VA is 0, VB we know is just going to the right. So then और RBA भी हमें पता है तो हम इसकी angular velocity find कर सकते हैं of the wheel. That is rate of rotation हमें पता चल जाएगी. And so on. So just have a think about this, okay? Think about the wheel problem as well. Okay. So moving on, one more example. As I've said, कि let's just practice this thing one more time. कि B और अब इस mechanism को consider करते हैं. Please note कि in this case, it is going to be general plane motion because BC का radius is much larger than A का. So let's say कि जब A यहाँ पहुंचा हो और B जो है इधर नीचे पहुंचा हो कहीं अपने पूरे सर्कल पे घूम के तो A B जो है वो यूं होंगे कुछ. That is, this is a case of both translation and rotation occurring for the bar AB. So let's draw in some of the information that we know. Clearly we know अगर हमें इनकी instantaneous positions पता हैं, so I know कि VB must be tangential to this circular path. That's why it's at इस तरह drawn है. And I also know कि AB is wheel पे confined है, so A must also be tangential to its circular path. So hence why A की इस तरह आ गई, right? So अब आगे क्या होता है? अभी let's say कि I'm hoping कि we have become quick enough for our analyses basically. We've become quick enough for our analysis right here. So तो अभी नहीं I'm just wondering, have we become quick enough कि हम directly try कर लें या पहले एक और दफ़ा break down कर लेते हैं फिर दोबारा कर लेंगे. Okay, so break down के अंदर क्या steps थे? 5 steps. First step was just to draw in as they are as the final resultant velocities. Then the second step is to just say कि हम उसको translation और rotation में तोड़ रहे हैं. So let me consider for now कि मेरा I'll take B to be my या फिर shall I take A? What do you guys? नहीं, I'll still take B क्योंकि B let's say omega rotate कर रहा है इसलिए I know कि क्या है. So B is my base point. So then everything moves by VB. And then add on top of it our B is going to be fixed, rotation about B. And as we said, we know that uski direction must be perpendicular to RAB, sorry. So if it's perpendicular, then let's go back here and draw these things in. So clearly VB कुछ ऐसे हो गया. और फिर ये by head to tail rule, then I have to go in this direction like so. So clearly I'm having to go upwards. So that is my relative velocity because of rotation is going to be upwards. So then I know that omega is anti-clockwise. And I figured out my entire velocity diagram. Okay, so this was my fourth step. Or ab, let me just draw. I hope this is clear. So let's just draw it all in together. वो जो fifth था उसको directly. First I'll draw in VA. Wow. Still quite bad, but okay, fine. Last try. This is fine. This is my VA. VB I know is at 45 degrees, so it's somewhere here. ये resultant था, by the way. And then finally it must be perpendicular to AB. So उसकी direction के बारे में मुझे पहले ही ये पता है कि उसने इस तरह का होना है, perpendicular to the horizontal. So this one right here is my VA by B. But of course 30 है, ये 45 है, so I know that this must be 15 degrees. And then again I can use trigonometry to figure it out. या फिर if I've already drawn it to scale, I can just measure off of them. ठीक? So guys, making sense? और ओमेगा का हमें समझ आ गया कि it was rotating. Omega AB was in this way, upwards, sorry, anti-clockwise. Okay. Any questions?
मैम ये VAB
Okay,
वर्टिकल
so
क्यों है,
let's
दोबारा
quickly.
बताइए.
VAB vertical क्यों है? VAB को, the only thing we know about VAB is कि it has to be, अगर हमने B को fixed किया हुआ था ना, B हमारा fixed था क्योंकि I was using that as my base point.
Yes.
All I know is कि it has to be perpendicular to R, to this thing, right? क्योंकि इस चीज का मतलब ये है कि A जो है घूम रहा है about B. तो अगर A B के इर्द गिर्द घूम रहा है तो उसने सर्कुलर पाथ बनानी है, और एज इट्स ड्रॉन राइट नाउ ये हॉरिजॉन्टल है, तो सर्कुलर पाथ का टेंजेंट इस वक्त ऊपर की डायरेक्शन में होगा. ठीक है जी.
यस मैम.
राइट. सो प्लीज नोट कि इसका ना we have to draw some of it to scale to figure out exactly क्या हो रहा है. तो अगर मैंने इसका कुछ थोड़ा सा उल्टा सीधा कर दिया तो मेरे पास ऐसा भी पॉसिबल है कि VAB नीचे आ रहा होता. लेकिन आई थिंक दिस सीम्स अ बिट टू स्केल, सो दिस सीम्स फाइन क्योंकि VA is at 30 degrees, VB is at 45 degrees, so this seems sensible. So from this we are seeing the relative velocity of A with respect to B ऊपर है. That means that at the next, remember this is all at this instant, just this is all instantaneous. Then for the next instant होगा क्या कि A has moved upwards from B. So अगले instant पे कुछ थोड़ी सी इसकी shape ऐसी सी होगी maybe, right? Because that's what it seems to me कि the velocity of A was upwards. So A would have moved up और B थोड़ा नीचे होता. Okay. I repeat if I have made a mistake in the scaling of this, तो इसकी वजह से इसकी direction उल्टी सीधी हो सकती है. Right, so we must actually draw these things to scale to do it completely correctly. But right now, I was just pointing out the steps to you guys. That's why please ignore if I have not drawn them to scale at the moment. Okay. Perfect. Right. So 1051 एक हम very quick example अगर कर लें please if you allow me. So we've discussed the procedure, so I'm not going to go into it. We've already said कि अगर वेक्टर हैं तो फिर तो सीधी सादी वेक्टर इक्वेशन के अंदर सब्स्टिट्यूट करें और अंधाधुन बगैर सोचे समझे क्रॉस मल्टीप्लाई एंड सो ऑन कर लें. Whereas the scalar approach, when we're drawing the graph, when we're drawing the graph, that one helps to think about the problem physically. Okay, so it is important to know. Sorry, मेरी आवाज. So it is actually important to know how to do that. One more thing that I forgot to mention for vector analysis, because I assume you guys know this, is कि जब I, J, K's को cross multiply करते हैं तो उसमें positive और minus क्या होता है? I hope you guys know that. So the reason is that we're looking at planar motion, so that's why our omega tends to be in the K direction, and then we're cross multiplying it by RBA. Sorry. So that would be some component in the I direction plus some component in the J direction. So clearly it's K crossed with I and K crossed with J. तो उसके लिए ना ये circular एक rule काफी काम कर रहा था कि if you draw I, J, K in this anti-clock to go into it. Perfect. So with that, just give me 2 minutes and let's quickly just do one example. So this is a mechanism similar to the one that we've already considered before in our example. और इसके अंदर क्या हो रहा है कि we know कि A is moving down with 2 meters per second and we want to find out what the velocity of B is at this instant. मतलब जब ये geometry है तब B की क्या velocity होगी. So right, as we know, I think हमने वो steps इतनी दफा कर लिए हैं कि we are going to be quick at this now. So I'll try to do it directly first. So in case मेरे को गलती होती है फिर I'll skip it. So VA I know is downwards, it's 2 meters per second. VA आ गया. Then the next thing I know is कि VB is going to be horizontal. So why don't I draw in कि उसने तो horizontal होना है ऐसे. What else do I know? I know the direction of VB by A. By the way, note कि मेरा A is my base point now. So मैंने translation की और फिर अब मैं rotation कर रही हूँ. I know that it is going to be perpendicular to this. It is going to be in this direction. Right? So that direction is this one right here. Or if this is 45 degrees, then I know that this is going to be 45 degrees as well. You're welcome to try it out and figure it out. So what do we get? VA plus VB by A is going to be equal to our resultant VB. और बिल्कुल straight forward इसी से हमें पता चल गया. We can see already from this VB by VA is equals to tangent 45. So I know then my VB is equals to 2 tangent 45. Which is, I'm not sure what it is. It's just 2. This was too easy. Maybe divided by VA. मैंने ठीक किया? Why do I get the feeling that this was too easy or I've got something wrong? No, it is. It's fine. Oh, wow. So just 2 meters per second directly. And we know it's to the right. So क्योंकि velocity पूछी हुई है, be careful. Velocity implies we need its direction as well. So VB, the vector is 2I, because it's to the right. I can see it from my graph, from my velocity diagram. 2I meters per second. Note that this is the velocity diagram. So I know I skipped a few steps and quickly got to the final one. लेकिन जो हमने 5 steps discuss किए ना, you all have to first do a few questions using that, ताकि you get to practice, and then you inshallah will be able to jump quickly as I have done right here. Okay. Otherwise, let's just stick to it. I love when इसको भी आप इतनी speed पे कर लेंगे कि we'll become pretty quick at that. So let me just quickly do that. So this is VA, this is VB, this is going to be split up into translation. Everything gets translated by VA plus rotation, where we're keeping A fixed. So I know कि मुझे इधर मैं वापस आती हूँ, मेरा पहला स्टेप ये था, मेरा दूसरा स्टेप ये था, तीसरा स्टेप है इसकी डायरेक्शन का ड्रॉ करना. That is of course just going to be this direction. Then fourth is to go back here, draw the things in here. This is VA. Oh, कोई मुझे ये पॉइंट आउट कर सकता था कि मेरा इतना दिमाग खराब हो गया कि मैं उसको हॉरिजॉन्टल बना के चलती जा रही हूँ. Guys, come on, please don't make me sound so crazy. Okay, sorry. They were like this. What was I doing? Everything. Again, I'm making a mistake. Everything gets translated. Plus then the rotation about A. Or that has to be perpendicular. Finally, so this is number 3. Then I go back here, I draw these things in. So VA niche ऐसे. And my direction तो मुझे पता चल गई है, so I then know कि this is going to be my VB by A. So this entire thing right here is my number 4. And that's it then. Just pop in the angles and solve it. ठीक है जी, any issues with this?